Hi, and welcome to the video on key features of functions. Specifically in this video, we're going to talk about y-intercepts, roots, and vertices. There are other key features that we will focus on later. This video is accompanied by a note packet where you're going to take notes on the examples that you see here, and we're going to begin on this slide. So make sure you have your note packet ready and you can take notes as necessary. Pause the video when you need to fill in the notes. All right, so we're looking at this graph here, and we're going to talk about three key features, as I said. The first is the y-intercept. That's where the graph crosses the y-axis. And when I say graph, I mean the line that is plotted there, or the curve. So if we're looking at this function, we notice that this graph crosses the y-axis between 2 and 3 on the y-axis. So that means we're going to have to estimate the coordinates for this point, and we get 0, 2.5. Notice that the x coordinate is equal to 0. Go ahead and make this note down. At the y-intercept, x is always equal to 0. Now the reason why that's important is because sometimes you have to apply that knowledge. You won't be told, but you'll have to apply it knowing that if you're looking at the y-intercept that x is equal to 0 to solve higher order problems. The next key feature are roots. Those are the x-intercepts. That's where the graph crosses the x-axis. So if we're looking at this curve here, we can see that there are 1, and then 2, and then 3 roots here. And what's important to note at the roots, or the x-intercept, is that y is equal to 0. Notice how that kind of switches there. So at the x-intercept, y is always equal to 0. The y-intercept, x is always equal to 0. And just like with the y-intercepts, for the roots, knowing that y is equal to 0 is something that you can apply to answer higher order questions. This is especially crucial in Unit 2, which is an up-and-coming unit. The last key feature are known as the vertices, or the vertex singular form. That's a turning point. So what I mean by turning point is if you're following this curve along from left to right is how we read it. We would go up, 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 and then the graph will start to go down, 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 and then up, 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 up again. So what happens is at these 2 points, the graph changes directions or turns, and those are our turning points. And so the first one is at about negative 0.7, 3.1, and the second one's about 2.7, negative 3.1. Notice how I just had to estimate the values of those coordinates because they're not on grid lines. All right, last but not least piece of information about vertices. We already know that the vertices are useful because they help us to classify a polynomial. So if we count the number of vertices, there are 1, 2 vertices here. We can add 1 to that. 2 plus 1 is 3, which gives us the degree. So we have a third degree polynomial, which is also known as a cubic polynomial. But what's really important to know for this video is that there are different types of vertices. So they can either be considered a maximum or a minimum. Maximum being at the highest point and minimum being at the lowest point. So look at this first vertex here. Would you consider that a maximum or a minimum? You're right, you probably would call it a maximum, but it's important to note, is this the highest point in the entire function here? No, it isn't. If you look on this right-hand side at the end, you notice that there are points that are higher than the vertex. And so we would call this a local maximum. Now, based on what you know from this example, let's see if you can classify this vertex. Like, what type of vertex is it? Great, it's a local minimum because again, it's at a low point, but it's not the lowest point in the graph since the left side of the graph keeps going down. All right, we have one more example to look at together. In this example, you're going to identify the y-intercepts first. So pause the video and press play when you want to reveal the answer. Great, so the coordinates for that y-intercept are 0, 4. Notice that x is equal to 0. Now try for the roots. Awesome, so you should see 2 roots here, negative 2, 0 and positive 2, 0. Now try for the vertex. Cool. You see that you probably notice that the vertex is at the same point as the y-intercept. Sometimes that happens. Key features will be found at the same position. Now let's see if you can identify what type of vertex this is. Is it maximum, minimum, local max, or local min? Great, it's a maximum. It's a true maximum because it's the highest point in the entire function. There's no part of this plot or this graph that's higher than this vertex. All right, now that we looked at some key features from the graph, we're going to look at key features from other representations, namely the equation and the data table. And we're going to start with the y-intercepts. This is the same graph we saw before, so we know the y-intercept is at 0, 4. So how can we apply the information? If you were given the equation and you wanted to find the y-intercepts, what do you always know is true at the y-intercept? You guessed it, x is equal to 0. So if you know a value for x is equal to 0, what can you do with that information to find the y-intercept? Yeah, you can substitute all of your x's for 0. So that's what we're going to do here. So on this side we'll have f of 0. Remember, that's the y value when x is 0. And whenever you see f of 0 for a polynomial, rest assured that you are looking at the y-intercept. So now we can go ahead and follow order of operations on the right side of the equation. 0 squared is 0, so and negative 1 times 0 is 0. We have 0 plus 4, which gives us f of 0 is equal to 4. That matches the information that we have here. The y-coordinate for this point is 4, and f of 0 is 4. Now let's try to see how we would find the y-intercept from the data table. So again, what do we know is true of the y-intercept? X is 0, awesome. So we're going to look in the x column of the data table, and we're going to look until we find x is 0. And that point where x is 0 is going to give us the y-intercepts. All right, let's move on to the roots now. So here are our roots. We identified those from before. We're going to find the roots from the data table. So what do you know is true at the roots? Right, y is equal to 0. So using the data table, which column are you going to start with? The x column or the y column? Remember, f of x is y. Cool, the y column. So, and what are you going to look for in the y column? 0. All right, so you're going to scroll down until your eye finds zeros in the y column, and then you're going to look over for the x value. And these are the coordinates of the two roots. Now, what about, this one's a little tricky. What about the vertex or the turning point? The thing to remember about the vertex or the turning point, that's where the graph changes direction. So in this graph, we notice that it's increasing, 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 or going up, 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 up until we get to that vertex there, and then it starts to go down. So how can we do that in the data table? Well, we use the information that we have about the trends to help us. So if we're looking at our data table, let's say we didn't even know what the graph looked like. I notice I go from 0 to 3 and then from 3 to 4. So my values here are increasing, but then I go from 4 to 3. So let's just focus on this area right here. I would say that that's an increase, and I can just draw on the side of that a up arrow to show that these values are increasing. And now from 4 to 3, I'm starting to go down, 3 to 0, 0 to negative 5, and then to negative 12. So all of these values are decreasing. They're getting smaller. And so I can draw a down arrow. So in between my up arrows and down arrows, that's where I'm going to find the vertex. Now it just so happens that in this case, the vertex is in the data table, but sometimes it's not. If the vertex is at a point where you have to estimate, or a decimal point, it may not be shown in the data table, but you can tell around where the vertex is. It's where the graph is changing direction. So the graph changes direction somewhere between the coordinate negative 1, 3 and 1, 3. And so you can identify that this graph from the data table would have at least one vertex. Okay, so now you're going to move on to the online practice and do practice questions in your practice packet. Hope you found this video helpful and have a quality day.